Hi there, Sergey from Core here. Today I'd like to talk to you about importing and exporting different types of CAD files using TT Toolbox version 2. If you've been working with any type of 3D modeling software for a while, then at some point you probably had to import an asset made in a different CAD program, or you had to export your model in a format compatible with some other modeling application. And Rhino, like everybody else, allows you to read and write your models in a number of common formats. TT Toolbox, however, takes it a step further and bring this import-export functionality directly into Grasshopper, allowing you to jump across CAD formats parametrically. So if we take a look at this Files tab in the TT Toolbox Grasshopper menu, then you'll see a number of components corresponding to a number of different formats. So we have 3DM, CAD, OBJ, STL, and SVG. And you'll also notice that we have two colors for each of those formats. So the turquoise component is for exporting your model to a certain format. And of course, if you're sitting there thinking that, well, Sergey, this color technically isn't turquoise, then be sure to let me know down in the comments. But in any case, this component, every turquoise component, will allow us to output a model that we put together in Grasshopper, or rather some geometry that we created in Grasshopper, into any one of those formats. And all of the orange components allow us to read a file stored on our local drive into Grasshopper as well. So let's try and test it out. I have a number of file paths that points to a set of STL files on my local drive, and let's just go ahead and plug this in. Now you'll notice that nothing seems to happen, and that's because we also have to switch this Boolean toggle to true. So let's go ahead and do that. And here we go. Here we have our Baby Yoda statuette. Now, let's just also add the custom preview, just so that we can see it a little bit better. But yeah, so what we just did is we loaded an STL file from my local drive, and it came through as a mesh, and that's just a regular mesh in Grasshopper. We can do whatever we want with it, whatever we usually do with meshes, and we can also bake it if we so desire. So right now, I bake it, and we just have a good old mesh in Grasshopper. All right, so now let's take a look at a couple of examples of how we can export geometry as different file types using TT Toolbox. So here I have some 3D examples. So here is a 3D Voronoi. Nothing special here. I'm just creating a bounding box. I'm populating it with some 3D points, using both of those to create a Voronoi 3D. And then I'm just finding centroids of each cell and then scaling them by some factor just so that we could better see each individual component. And then I'm using the volume information of each cell to drive the gradient component. So I'm generating a color based on the volume. And now I want to save all of this as an OBJ file. So how do I do this? So first of all, we need to provide our export OBJ component with the geometry that we want to bake. So we take our meshes and we pipe them straight into the geometry input. Now we want to bake color into this mesh as well. You may be tempted to use the mesh color component in Grasshopper, which essentially mesh color, let's see where it is. Yeah, mesh colors. So mesh colors would vertex color your mesh. This works in a lot of cases, but not this one. If we pass a vertex color mesh into this export component, we will not get the colors on the other end. Instead, what we need to do is specify a material through the attributes. So here I have the construct attributes component that can be found here. And then I'm measuring how many meshes I have. So in this case, I have 100 meshes. And I'm using the GUID component in our utilities to create 100 unique names. If you don't know what a GUID is a globally unique identifier. It's just an algorithm that allows you to very easily create a very, very large number, I'm talking trillions potentially, of strings while having very high confidence that none of those strings will repeat. So we're just using this to name our attributes and create 100 attribute objects. And now I have to set the material as part of these attributes. So I'm going to be using the set material component right here. And I'm taking my gradient colors and I'm passing the colors in the diffuse color input on the material. And then we can play with other properties such as roughness, metalness, so how metallic the material looks. I'm setting it to 1 for fully metallic. We can set opacity. We can set emissive color, basically your standard material stuff that you're probably familiar with. And then we take 100 of those attribute objects and are passing them alongside our geometry into the attributes input. A couple of other things that we are required to specify. So the directory where we will be saving our OBJ. So I'm going to be saving it right here. And the file name. Note that I am not specifying the file extension because the file extension will come from the export component. We're exporting an OBJ, so TT Toolbox knows to mark it as a .obj. So now we are all set. I'm going to flip the toggle on, and you'll see that we have 2 new files in this directory. So we have the OBJ file and the MTL file, which is the material that we just specified using our attributes right here. So let's go ahead and take a look at this OBJ. I'm just going to double click on this to view it in my 3D viewer. And here we go. We have a 3D mesh colored just as we specified it. And we can view it in another application. With 2D geometry, the process is very similar. So here I'm just creating a Voronoi by creating a rectangular boundary, populating it with points, passing this to the Voronoi component, then turning every cell into a planar surface, and then just measuring its area. Similarly to what we did here, I scale each cell around its centroid, and then it's just a matter of passing our curve geometry and our surfaces to the SVG output in this case. So with SVGs, we're actually able to pass both curve geometry and surfaces. NURB surfaces will just be converted to curves. So there's a nice little flexibility built in there. So in order to color my geometry, I am going to use a very similar process as we did for the 3D Voronoi. So I'm going to construct attributes using GUIDs. But instead of assigning a material, I'm going to assign the graphics with a set graphics component. And here I can control the stroke weight, the stroke pattern, the fill color, and the stroke color. So for the Voronoi cells that right now I have as curves, I'm just using a black swatch, and I'm just setting the stroke color. And for the filled-in cells, I'm setting the stroke color and the fill color. And now the SVG export component has some slightly different options compared to the OBJ one. So first of all, we're passing all of our attributes, just like we did for OBJ, into the attributes input. The directory path and the file name is pretty much the same, but we also have units. So here I'm working in pixels right now, but we can switch to millimeters, centimeters, or anything else that makes more sense for your use case. And let's just go ahead and turn this on, and we'll go to the folder, and let's see what we made. And here we go. All of our curve geometry came through as black lines, and all of our surfaces became filled regions. Once again, we didn't actually have to use surfaces to make the fills. These are filled in the SVG because we specified the fill color as part of our graphic. Well, and that's all I have for you today. Thank you very much for watching, and I'll see you next time. Bye-bye.